Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2021, paper 4, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1. Calculate 6 squared plus 5 all cubed. Okay, now this is the calculator paper, and if you've got a decent calculator, then this question is no problem at all, is it? So I'm just going to type it exactly as on the page, open brackets, 6 squared plus 5 close brackets to the power of 3. That comes out to be 68,921. Okay, so presumably by now you do have a decent calculator. 6, 8, 9, 2, 1. If you don't, I'm gonna give you a couple of recommendations to take away. I do highly recommend the Casio calculator. As you can see, the emulator that I use in all my videos is a Casio one. So I'll put a link into that in the description below, and also a link to my Amazon shop up here now for you to have a quick look at if you don't have one already. But if you're thinking about doing A-level maths next year and you're looking for a new calculator, I do recommend spending a little bit more now and getting the FX991EX instead, which is about twice the price, but we'll see you all the way through A-level. If you get the cheaper one, then you're gonna have to throw that away when you're not going to you're gonna have to get another calculator anyway when you go up to A-level. So yeah, just bear that in mind. And the white one has got a few extra functions actually you can make use of at GCSE, so it's a good result all around. Now the second one, again, I'm going to type it in exactly as it is on the page. So square root button first. I'm then going to use the fraction key so I can kind of emulate what's on the screen there and write it down the same way. Then 8.4 squared minus 1.9 squared on the top. And then press the down key to go to the bottom part of the fraction, 2.5 plus 5.7. Now it should look on your calculator the same way as it does on the screen if you've got one of these Casios. So when it looks exactly the same, I'm just going to press equals, and you can see I get 2.8573 and so on. We need to write our answer to correct to 3 significant figures, which is the first 3 non-zero digits. That means I need to round off after the 5. Next digit is a 7, which means I need to round up. So my 2.85 becomes 2.86. Okay? Question 2. Calculate the area of this trapezium. Do you know the formula for the area of a trapezium? It's area equals a half a plus b times h. Now, the first part, a plus b, is those two sides, isn't it? It's your two parallel sides added together. And then you divide it by 2. What you're basically doing here is you're finding the average of those two lengths. Kind of you're squishing one in and you're stretching one out so they both match. So you find your average of those two lengths, and then you simply multiply it by the distance between them there. So I'm going to multiply it by that one there. Okay, so let's just sub that into my formula. So half A is one of the parallel sides, 8.7. B is the other one, 12.3. H is the distance between them, that's 6.8. Okay, right, so I like to do what I can in my head, so it just makes type it into the calculator easier. So that's like half 8.7 plus 12.3. I make that 21. Okay, you could just type the whole thing in if you wanted to. 0.5 times 21 times 6.8. But I feel like if you're quite good at arithmetic, then you're less likely to make a mistake doing the maths than you are typing in into the calculator. That's my theory on it. Anyway, 71.4 is the answer. 71.4 centimeters squared. Question 3. Simplify x to the power 12 divided by x to the power 4. So here we've got some division of two numbers with the same base to different indices, haven't we? You've got 12 and 4 there. So when you divide numbers with the same base, you're going to get the same base, but and then you're going to subtract the indices, aren't you? So this is going to be to the power of 12 subtract 4. So the base stays the same. We just subtract one index from the other. 12 subtract 4, that is equal to x to the power of 8. That's my final answer, x to the 8. Question 4. Lee throws two fair four-sided dice, each numbered 1, 2, 3, 4. Lee multiplies together the two numbers that the dice lands on to produce a score. Find the probability that Lee's score is a prime number. Okay, so Lee has got two fair four-sided dice. Have you seen four-sided dice before? They're actually the shape of a little pyramid. Okay, you might have seen them before. So, if you have, probably you played Dungeons and Dragons or something like that. But anyway, they're fair, which means that each side comes up with equal probability. And we're going to roll two of them and multiply the scores together. I think I'm going to express this as a sample space. So I'm going to make a little grid. And I'm going to put the numbers 1, 2, 3, 4 in that direction for the first dice, and 1, 2, 3, 4 in that direction for the second one. Now, normally when we're doing these sample spaces, we're adding the scores together, and you're probably aware of that kind of pattern that you get with the 7s running down the diagonal, if you've done this before. But here we're going to multiply them together, aren't we? So 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 4 1s are 4, 4 2s are 8, 3 4s are 12, and 4 4s are 16. So you should see that we've got 16 different outcomes here. Which ones are prime? Well, prime numbers 2, 3, 5, 7, 11. We're going to have some 2s here, aren't we? We've got a 2 and a 2, and we've got a 3 and a 3. Any more? No, all the rest are even numbers, aren't they? And I've got 1, so it's just those 4, isn't it? So what is the probability that the result is prime? Probability is successful outcomes over total outcomes, isn't it? Successful outcomes over total outcomes. Now we just highlighted 4 numbers here, 4 primes in my list of results. They are the successful outcomes, aren't they? If you get a prime, then that is success. And then we're going to divide it by the total outcome, and we just said that there were 16 different values in there. 4 times 4 is 16. So we've got 16 different outcomes. So that's 4 out of 16. Now you could cancel that down to 1 over 4 if you want to, or you can just leave it as 4 over 16. It doesn't say write it in its lowest form. And normally in probability you don't get any credit for doing so. So up to you. If you want to cancel it down, cancel it down. If you want to leave it as 4 over 16, feel free. Question 5a. Fountain A squirts water every 24 minutes. Fountain B squirts water every 42 minutes. They squirt water together at 15:19. Find the next time they squirt water together. Now, I've spotted straight away what this problem is about. Have you? When you are doing problems like this, where you've got an event that occurs at the same time, which it does at 5:19, and then you've got two other events that happen at different time intervals, and you have to work out when they happen again. This is an LCM question, okay? Because basically you want to get to the same number on both squirts, don't you? And then that is going to be the next time that they squirt together. Okay, so we want the LCM of those two numbers. Now, you've got different methods for finding LCM, some of which are better than others. Normally, I would recommend, especially when you've got larger numbers like this, that you do prime factor decomposition to find your LCM. I'm going to show you that way first, and I'm going to show you another way if you struggle with it that you might like to try. Okay, so first off, LCM of 24 and 42 using prime factor decomposition. I'm going to write 24 and 42 as a product of their prime factors. I could do that by simply typing the number in, 24, pressing equals, and then pressing shift, and then the fact key. And I can see that that is 2 cubed times 3. 2 cubed times 3. And then the same with 42. 42 equals shift fact. That comes to be a 2 times 3 times 7. Now, when you've got your numbers both in factor form like this, what you're going to do is you're going to pull out every base that appears. So I've got a 2 that appears in both. I've got a 3 that appears in both. And I've got a 7 that just appears in one. Now, it doesn't have to appear in both of them, just one or the other. Okay, so my LCM is going to be made up of the bases 2, 3, and 7. And then you go through and you pick out the highest power of each and write that next to your 2, 3, and 7. So you can see my 2s. I've got a flat 2 in the 42, but I've got a 2 cubed in the 24. So I'm gonna pick the higher one. So I'm gonna pick the 2 cubed. It's just 3 to power 1 for both, and it's just 7 to power 1 in one of them. So the others stay the same. So that is my LCM. 2 cubed times 3 times 7. Well, 2 cubed times 3 I know is 24, so I'm just going to do 24 times 7. It comes out to be 168. Okay, so we know then that the LCM of 24 and 42 is 168. So it's going to be they're going to simultaneously squirt 168 minutes after 1519. So what's 168 in hours and minutes? So if I do 168 divided by 60, that comes out to be 14/5 or 2.8. Now if I then press the kind of time key, it's like a minutes, it's the 0 dash double dash button. It will convert it into hours and minutes for me. So can you see it's gone to 2 hours 48. So this is equal to 2 hours and 48 minutes. Okay, so then I need to add on 2 hours and 48 minutes onto 1519. Okay, so 2 hours and 48 minutes onto 1519. 1519 add 2 hours and 48 minutes. What's that then? So remember, when you're adding time, it's kind of like in base 60 actually. Thank you, Babylonians. So I got 19 and 48 to add here. So adding those together, 19 plus 48, 58, 67, isn't it? Which is an hour and 7 minutes. So what I'm going to do is I'm going to write that as 7 minutes and kind of carry the 1 hour over into the next column. And then I've got 15, 16, 17, 18 then. So that is 1807. So the simultaneous squirt is at 1807. Okay. So that's probably the way I would do it. Now, if you struggle with that, there is perhaps a simpler way of doing it, and that's just using well, I'll show you on the calculator. I'm going to use that that button again that I just showed you for time. So I'm going to type in 15, and I'm going to press that little symbol, and then I'm going to type in the 19, and I'm going to press that little symbol. So that's 1519. So you can see if I press enter, it comes out to be 1519. Okay, then what I'm going to do is I'm going to press answer, so the last calculated time plus 0 little circly thing 24. So what that, and then little circly thing. Right, so what that's going to do is going to take the value that I pressed into the calculator a minute ago, which was 15 hours and 19 minutes, and it's going to add on 0 hours and 24 minutes. And if I press equals, you can see it's come to 1543. Okay, so what I would do here, so for the 24-minute squirt, so fountain A, I would do so the start time at 1519, and then the next one is at 1543. Okay, and then what I'm going to do now is just press equals again, because I used the answer key to set it up. If I just press equals again, it's going to add another 24 minutes onto my original answer. You can see I get 16.7, which is 1607. Okay, and then I'm going to press it again, and I'm going to get 1631. And I guess you get the idea. I'm just going to press this a few times. I'm going to maybe write down when it's going to stop, and I don't want to have to set it up again. So I'm just going to write probably more than I need, because I don't know this way, because I've already done it, but I don't, I don't want to cheat. So I'm just going to carry on writing some down. So 1831. I'm going to do about 10, I suppose. How many have I done? 1, 2, 3, 4, 5, 6, 7, 8, 9. One more. 1855. Okay. So there are all the times that fountain A goes squirt. Now let's do fountain B the same way. So I'm going to show you again what I did on the calculator. So for fountain B, I'm gonna set up the original time. So I'm going to press 15, little circly thing, 19, little circly thing, and then press equals. So you can see it's got 15, 19, and 0 seconds displayed here. Okay, and then I want to take my answer and add on to that 42 minutes this time. So that's 0 hours, so 0 little circly thing, 42 little circly thing. Okay, and then that gives me 16.1, which is the first time 42 minutes after 1519. So 1519, 1601, and then this time I'm going to go until I'm going to do a few, and then I suppose I could just do 10 and then look at my list, or I could look at my list as I'm going along and see if I get to one that matches. So 1725, 1807. Hold on a sec, I recognize that one. And then you can say, oh look, I had an 1807 there and an 1807 there. So that be my answer. Okay, so which way is better? Now the first way is more mathematical, might be more quicker if you're quite good with your LCM finding. If you struggle with dealing with time and you quite like the calculator technique I just showed you, that might be quicker for you. Okay, which one scores the most marks? They both score exactly the same marks, so pick the method that works for you. Question B, a school sends 60 students from year 8 and 105 students from year 9 to a museum. The school divides these students into groups using the following rules. The group must be all the same size. All students in the group must be from the same year. There should be as few groups as possible. Find the size of each group and the total number of groups. Okay, so here, this isn't an LCM this time. This is a HCF question, isn't it? Okay, so basically what I want to do is find the highest common factor of 60 and 105, and then that is going to be my group size then, isn't it? Okay, and then I can work out how many groups that I need for each. Okay, so let's do that. How do I find the HCF of two numbers? Again, you could just kind of do it exhaustively. You could do 60 and find all the factors: 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7, nope, 8, nope, 9, nope, 10, and I've got to where I've got to, haven't I? So there are all the factors of 60. Let's try 105. 105 is 1 and 105. 2, nope, 3. Yes, 3 goes into 105. It is 3 and 30. 5. Is that right? Yeah. 4, nope. 5, yes, yes, yes. 5 goes in 21 times. 6, don't think so. 7 and 15. 8, don't think so. 9, no, definitely. 1 and 5 makes 6, not a multiple of 9. 10, no, and 11, no, and 12, no, and 13, no. Okay, so they are, I think they're all the factors there. Okay, so I can see straight away which is the biggest one. It's going to be that 15 then, isn't it? Which is on both lists. So 15 then is the HCF of these two numbers. Now you can do this with prime factor decomposition as well. I think finding all the factor pairs of these large numbers is too long. I would personally do it using prime factor decomposition. So again, using the factor key on your calculator, 60 equals shift fact. That's 2 squared times 3 times 5. I'm going to write it long this time. And then 105 equals shift fact. That's 3 times 5 times 7. And then the HCF then is the numbers on both lists. So you can see I've got a 3 and a 3 and a 5 and a 5. So then the HCF then is going to be 3 times 5. So that was definitely a lot quicker doing it that way than the other way. I found doing all those factors quite long. So anyway, now I've got that the HCF is 15. That is the size that the group is going to have to be then, isn't it? That's going to be, so I can make the group size 15. That means they're all going to be the same size. All the students in any group must be from one same year, because 15 divides into 105 students from year 8, or 105 students from year 9 and 6 students from year 8. And there should be as few groups as possible. So that is the largest size it can be. So the size of each group is going to be 15 students. Total number of groups then, well, for year 8, there are going to be 60 divided by 15. What's that? That's 4 groups. And then for year 9, I'm going to have 105 divided by 15, and that's 7 groups. So altogether then, that's 11 groups. So 11 groups. Question 6. A shop sells the same milk in 3 different size cartons. The diagram shows the price of each carton. So you can buy it for 300 millilitres for 31p, 500 millilitres for 47p, or 2 litres for £1.96. Which carton is the best value for money? Show how you decide. Now, your kind of natural instinct would be the bigger one would be the cheapest, but shops, they're a bit naughty sometimes, and it doesn't always work out that way. So good to check. Now, to work out the best amount, we need to have a standardized amount. So it doesn't actually matter what that amount is. We could work out per milliliter. We could work out for a litre, or we could find something that they all go into. Now, the strategy depends on the paper. This is the calculator paper, so it doesn't really matter so much what number you pick. If it's a non-calculator paper, I'd probably pick a number that they all multiplied into, like a common factor or common multiple of those, a bit like, you know, you do with fractions. I'd be looking at 300 to 500 and 2000 and coming up with an LCM of those, and then maybe scale them all up. But because I've got my calculator here, it doesn't really matter so much. I'm just going to make it like, I think maybe a litre. So that should be fairly easy to do for each of them, especially for the last 2. The first one might be a little bit harder, but anyway, we'll get there. There's no problem. Right, so let's have a look at the 2 litre one. So the cost for 1 litre of that then, what is the cost of 1 litre? So 1 litre is going to cost £1.96 divided by 2, isn't it? Because you've got 2 litres in there. So if I divide it by 2, I'll get the cost of 1 litre. So what's 1.96 divided by 2? 1.96 divided by 2. So that costs 98p for 1 litre. Okay. Now for the 500 millilitre, if I double that one, I'm going to get a litre, aren't I? So 1 litre of this one is going to be what, 47p times 2 then, isn't it? So 0.47 times 2. That comes out to be 94p. See, supermarkets, you got to watch them. 94p there. And then the 300 millilitre one for 31p. This was a little bit trickier to do. 1 litre here what I'm going to do is I'm going to take 31p, I'm going to divide it by 3, that will tell me the price for 100 milliliters, sorry, and then I'm going to times it by 10. So I'm going to basically find 10/3 of 0.31. So 0.31 divide by 3 times by 10, that should tell me the cost of 1 litre. That is £1.03 reoccurring. So that's just £1.03 to the nearest penny then, isn't it? Okay, so you can see now, because I've got the same amount for each one, I've got 1 litre there, 1 litre there, 1 litre there, then I can compare the prices quite easily. So I can see here that the best value for money is that one there, isn't it, 94 pence. Okay, so which carton is the best value of money? 500 milliliter carton is best value. Now it says show how you decide. I kind of already did that. I'm not going to rehash it again. You know, my argument is a mathematical argument, and I've written it out here, haven't I? This is my argument here. I don't need to rehash it again into words. My mathematical argument stands. Part B says a student only buys milk on a Saturday morning. They use 120 millilitres of milk each day. Any unused milk is to be thrown away at the end of the following Friday. Show that it is cheaper for the student to buy milk they need in 300 millilitre cartons than in 500 millilitre cartons. Yeah, so whilst 500 millilitre is the cheapest per milliliter, if you're going to end up chucking a lot of it away, then maybe it isn't the cheapest way for you to buy milk. Maybe it's better to buy the smaller one. Let's just double check that. So they use 120 millilitres a day from Saturday through Friday. So that's 7 days, isn't it? Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. So their total milk consumption for the week then is going to be the 120 millilitres per day times the 7 days of the week then, isn't it? So 120 times 7 comes out to be 840 litres, 140 millilitres. Okay, so in order to have 840 millilitres of milk, then they're either going to have to buy 3 of those on any given day, or 2 of those. Okay, so that's enough, isn't it? 3 lots of 300 is 900 millilitres. Or I could do 2 lots of 500 millilitres, which is 1,000 millilitres. Either way, I've got enough milk for the week then, haven't I? Okay, now one less would not be enough. I suppose I could buy 2 of the 300 millilitres and 1 of the 500s, but I'm not sure that's not going to work out any cheaper, is it? So they're my 2 options. So either buys 3 lots of 300 millilitres, which is 3 times 31 pence, which is, what's that? 3 lots of 31, that is 93 pence. Or he buys 2 of the 500 millilitre packs, which is 2 lots of 47 pence, which comes to, I suppose you put 0.47, and 0.47 times 2, that comes out to be 94 pence. So it's a penny more expensive. Okay, so at the end of the day, he's chucking away slightly less milk if he buys the 300 millilitres one, because he's only wasting 60 millilitres, plus he's saving a penny. So that's the better deal then, isn't it? If he's going to be not wasteful and also saving himself some money. Okay, so I'm just going to conclude cheaper to buy 300 millilitre containers. Question 7 part A. Over a long period of time, it's found that the probability of a train from Beaufort to London being late is 0.2. One morning, there are 2 trains from Beaufort to London. Use the information to complete the tree diagram. Okay, so presumably it is a independent thing. So the first train is late is the same probability as the second train being late. And remember that any pair, any branching pair like this represents completion, so they have to add up to 1. So if the probability of it being late is 0.2, then the probability of it not being late is 1 minus 0.2. That's 0.8 then, isn't it? So these two need to add up to 1. Okay. Now, with the absence of anything to tell me any different, the second train, I'm going to assume it has the same probability of being late and therefore the same probability of being on time. And it doesn't matter if the first one was late or on time. It's going to be the same down here as well. Okay, so here I should have 0.2 and 0.8 on every branch. Part 2 says work out the probability that both trains are not late. Okay, so which branch are we going down? We're going down the not late branch then, aren't we? So the probability of not late, so I use a little bar on top of the L. So if I use L for late, then L bar is going to be not late. So the probability of not late is going to be the probability of not late, which is 0.8, times the probability of the second not late, which is also 0.8. 0.8 times 0.8 is 0.64, isn't it? Okay, so it's 0.64. And then part 3 says, give a reason why the probabilities used in the tree diagram for the second train may not be reliable. Now this tends to be the fact that we assumed then that the probability of each train being late was independent of all the others. Well, that's probably not the case, is it? If you think, if a train is late, it's normally because there's a fault on the line or there's like a backlog, and that tends to cascade all the way through the rest of the day. So, one train being late has a knock-on effect of all the others. So I think you'll probably find that they are dependent, and one train being late is probably going to make it more likely that the next one is going to be late as well. So I'm going to sum that up and say we assumed that the probability of each train being late was independent, okay, but one train being late could easily affect other trains. And then in brackets I've put dependent. So I think they're probably dependent, aren't they, rather than independent probabilities. Okay, but that's the assumption. We assume they're independent, and that's probably why our estimate is probably wrong. Gosh, this is a question that keeps on giving, isn't it? So this is part B. Morgan takes a train from London to Beaufort and then another train to Agon. The tree diagram shows the probabilities of Morgan's trains being late or not. So the train to Beaufort, probability that it's late is 0.35 and on time 0.65, and then to Agon is 0.24 and 0.76, and that's on both branches. Morgan will not catch the train to Agon if the train to Beaufort is late and the train for Agon is not late. Work out the probability that Morgan will catch the train to Agon. Okay, so Morgan will not catch the train to Agon if the train to Beaufort is late and the train to Agon is not late. So first train late, second train not late, that is a no-no. So this one, late, not late, that is not going to work, because if the first train is late, it's going to arrive, and the second train is not late, it means the second train will have left the station before the first train arrives. So that route is not possible. Okay. However, if the first train is late and then the second train is late, even though the first train is late, the second train is late, so he's still got a good chance of catching it. So that one works. And obviously, if it's on time, then it doesn't matter if the second train is late or not, he should still be able to catch it. So in other words, all the routes are good apart from that one there, the late, not late one. Okay, so the probability then of him catching the train, I could say it's all those three roots added together, but when you've got three roots that are the ones you want and one root that isn't, it's often quicker to flip it on its head and do it the other way around. So I'm going to work out the probability that he doesn't catch his train to Aegon and then take it away from 1, and that will give me the probability that he does catch the train. Does that make sense? So that's going to be 1 minus the probability of late, not late then, isn't it? Okay, so the probability that the first train is late but the second train is not late. That's the only option that you can't catch the train. So that's going to be 1 minus 0.35 for the late probability multiplied by 0.76 for the not late probability. Okay, so what does that then? So 1 minus 0.35 times 0.76, that comes out to be 0.734. Okay, so that is the probability of all of those three other branches, okay, added together, 0.734. Now, like I say, you could have worked all those out. You could have done 0.35 times 0.24 and added on 0.65 times 0.24 and added on 0.65 times 0.76. It would have just been longer, okay? But perfectly acceptable to do it that way. Question 8. Jamie invests £6,000 at simple interest rate of R% each year. After 6 years, the value of the investment is 7,170. Find the value of R. So I'm going to use my little FOM triangle, final original multiplier. Okay. So in this case, the final amount is what happens after the investment has taken place. That'd be this one here, isn't it? 7,170. That's how much money he's made. He's got at the end. Okay. The original. So that's the final. The original amount is what he started with. That's this up here, isn't it? It's the 6,000. So I'm going to write that here. This is 6,000. Now we know the multiplier has got something to do with this R here and the fact that we are applying it for 6 years. We're going to use that information in a minute, but I'm just going to work out what the multiplier is meant to be equal to first from the information I've got here already, and I'm going to come back to that 6 lots of R. So, like, covering up the multiplier that I want to find, M, the triangle tells me that that's F over O. So multiplier is equal to final over original, which is 7,170 divided by 6,000. What's that then? 7,170 divided by 6,000. That comes out to be 1.195. Now that's a multiplier. Now 1.195 as a percentage, if I multiply that through by 100, that's going to give me 119.5%. But remember, this is a percentage increase, isn't it? So it's an increase of 19.5% increase then. Okay, so it's a 19.5% increase because you start with 100%, and if I've now got 119.5%, it's gone up by 19.5%. And that's going to have to be equal to our value of R times 6, isn't it? 6 lots of R is going to have to be equivalent to 19.5, isn't it? Because I've applied the R% interest rate 6 times over, and it's gone up by 19.5%. So 6R must be 19.5. So then dividing 19.5 divided by 6, that tells me that R must be 3.25. So R equals 3.25%. Okay? 3.25. More percentages for question 9. The price of a plane ticket is increased by 15% to £1,426. Find the original price for the plane ticket. Okay, time to get my FOM triangle out again. Final original multiplier, FOM, stick your thumb on it, OM. And then read through the question, try and work out what's what. Now, I'm usually given two of these things and need to find the third thing. So which one am I given and which one do I need? Now this one here, look, is that the final price or the original price? The price of a plane ticket is increased by 50% to 1426. So that is the final price, isn't it? It was a price, it's increased, it's now a 1426. I'm going to write that there. So 1426. So then that makes the original what we're trying to find then. Find the original price. So that's the one we want. Multiplier. Well, I can see that my price is increased by 15%. So again, look, we start with 100% and then we're increasing it by 15%. So we've got 115% to find, which is 1.15 as a multiplier. Okay, cover up the thing you want to find. I want to find the original price. So that tells me that the original is equal to final divided by multiplier. That's why I like this little triangle. You can use it for every question for percentages. Final is 1426. Multiplier is 1.15. Divide. What do we get? 1426 divided by 1.15. That comes out to be 1240. So the original cost was £1,240. 1240. Question 10. Alex, Blake and Charlie play a computer game. Alex goes first and scores n points. Blake scores 8 points, less than 3 times the number of points scored by Alex. It's a bit complicated. Charlie scores 25 more points than Blake. The three people score a total of 618 points. Work out how many points they each score. You must show you're working. Okay, so we're going to have to form some various expressions, aren't we, for Blake and Charlie's score based on the n points that Alex scored. We're then going to add them all together and then hopefully find out what n is, and then we can work out what the three chaps scored. That is the plan. Okay, so we know that Alex scored n. Okay, so he's just got n. Blake scored 8 points, less than 3 times the number of points that scored by Alex. So 3 times the number of points scored is 3n, and 8 points less than that, that is 3n minus 8. So Blake scored 3n minus 8 points. 8 points less than 3 times the number of points scored by Alex. So Alex scored n, 3 times that is 3n, take away 8 is 3n, take away 8. Okay? Charlie scores 25 points more than Blake. So we know that Blake scored 3n minus 8. So Charlie scored 3n minus 8 plus 25, which I suppose is the same thing as 3n plus, what's 25 take away 8? That's 17, isn't it? So 3n plus 17. Okay? So we know Alex's score, it was n. We know Blake's score, it was 3n minus 8. And we know Charlie's score, it was 3n plus 17. And we know that the total was 618. Okay? So what we're going to do is we're going to take Alex's points, we're going to take Blake's points, and we're going to take Charlie's points. We're going to add them together, and it's going to give me 618. Okay? So n plus 3n minus 8 plus 3n plus 17 equals 618. So Alex's points plus Blake's points plus Charlie's points is equal to 618 points. Okay? So let's just collect like terms together. I've got n, 3n, and 3n. That comes to 7n. I've got minus 8 plus 17. That comes to plus 9. And that's equal to 618. Okay? So let's deduct 9 from both sides to simplify things a little bit. So then I've got 7n is equal to 609. I'm hoping that divides by 7. That will make me very happy. divided by 7. Yeah, n equals 87. Okay, so we know that's what Alex scores. I'm going to write that one straight in, 87. Now, Blake's score was 3n minus 8, wasn't it? So that now we know is equal to 3 lots of n, which I know is 87, minus 8. What's that then? So 3 times 87 minus 8, that's 253. He whooped you. Okay, 253. And then Charlie was 3n plus 17. So that's going to be 3 lots of 87 plus 17 then, isn't it? What's that? 3 times 87 plus 17. That comes to 278. Clear victory, Charlie. Well done. Question 11. The diagram shows triangles ABC and ADE. You can see that ADE kind of lies on top of ABC, isn't it? And it shares some sides. B lies on AD and C lies on AE. BC is parallel to DE. All this information is shown on the diagram. Complete these statements to show that triangles ABC and ADE are similar. Okay, so to show two triangles are similar, basically you've got to show all their angles are the same. And then, yeah, then you can say that they're similar. So angle ABC is equal to angle ADE because they are corresponding angles. ABC, this one, is equal to ADE, this one, because they're corresponding. Yeah, you've got a pair of parallel lines, you've got a line crossing them. This one is equal to this one, isn't it? Okay, they're corresponding angles. That is correct. Okay, angle ACD is equal to what? Angle ACB, sorry, is that one there, is equal to what? Because what? Okay, well, you can say again it's going to be that one there, isn't it? You can say that these two are also corresponding for exactly the same reason as the other ones are. So that is angle AED, isn't it? So ACB is equal to angle AED because they are corresponding angles. And angle BAC is the same as angle DAE. Okay, so this angle here, look, BAC, that's the same as this angle DAE. Well, because look, they're just extensions of the same line, aren't they? Okay, so angle BAC is the same as angle DAE. Triangles ABC and ADE are similar because all three matching angles on each triangle are equal. Question 12a. The region R is shown on the grid. You can see the region R there. It's bound by the y-axis and 3 lines there. So one of the inequalities is x is greater than or equal to 0. That's basically the y-axis here, isn't it? X is greater than or equal to 0. X equals 0 is the equation of the y-axis, and we're basically off to the right of that, aren't we? So the x coordinate has got to be bigger than 0 to be part of this range, isn't it? Okay. Okay, use the symbols less than or equal to or greater than or equal to complete the other 3 inequalities. Is y less than or equal to a half x, or is it greater than or equal to half x? I think probably the easiest way to tell is to pick a reference point. So just pick a point somewhere in your region. I'm going to pick the point 4, 5. This is the point 4, 5. It's smack in the middle of my region. So if x is 4 and y is 5, is y bigger than half x or is it smaller than half x? Is 5 bigger than or smaller than 2? Half of x, half of 4 is 2. 5 is bigger than, isn't it? So it's going to be that way around. Y is going to be bigger than a half x. Okay. Is x plus 2y bigger than or less than 24? So if x is 4 and y is 5, then 4 plus 2 lots of 5 is 14. So 4 plus 2 lots of 5, what is that compared to 24? Is it bigger or smaller? Well, 4 plus 2 lots of 5 is 14, and 14 is smaller than 24, isn't it? So it's that way around. And then finally, y and x plus 6. Well, if y is 5 and x plus 6 is going to be 4 plus 6. Is 5 less than or greater than 4 plus 6? Well, 4 plus 6 is 10, isn't it? And 5 is definitely less than 4 plus 6. So I'm going to put it that way around. Okay? So that was just, picking a random point somewhere in your region and then testing each one of those to work out which way round it goes. Okay? Don't know why it keeps wanting to write a H instead of the correct symbol. So that should be greater than or equal to again. I do apologize. So the inequality x is greater than or equal to 0 is replaced by a new inequality. Okay, write down the new inequality. So the inequality x is greater than or equal to 0 is replaced by a new inequality. Region R is then a kite. So I need to make a kite out of this thing by replacing the yellow line. So I'm going to have to come in with a new line. So I'm going to make a kite, aren't I? Okay. So presumably this is like the long bit of the kite. I don't know if you can see. Does that make sense? So we're going to get a kite that looks a bit like this then, aren't I? Okay. So we've already got like this bit and this bit and this bit. This bit, this bit, this bit. What we want to do is kind of add on this extra little bit somewhere here, look, to make it work. Okay, so what is that line going to look like? Well, what's the properties of a kite? Properties of a kite are that not opposite, but adjacent sides are equal in length. So if you have a look at this side here that I've left green, that is 1, 2, 3, 4 units along and 4 units up. So if I want to do one which is matching in length, then I'm going to have to go 4 units down and 4 units across then, aren't I? So it's going to have to go off in that direction then, I reckon. Okay, it's going to have to be that line there to make this a kite. And if I do that, then I know that's a kite because that length is the same then as that one, because 4 units long, 4 units up, 4 units long, 4 units down. And then the other side here, that is the same as that, isn't it? Because if you count from here to here, that's like 1, 2, 3, 4, 5, 6, 7, 8 units along and 4 up. And that's also 8 units along and 4 down. So those two lengths are the same length as well. Okay, so all I've got to do then is come up with the equation of that new line that I've drawn. Okay, well, the equation of the line is always of the form y is equal to mx plus c, isn't it? Where m is the gradient and c is the y-intercept. So c is where it crosses the y-axis. So you can see kind of cuts through the y-axis there at 6. So my c value is going to be 6. So c is equal to 6. Okay, what's my m value, my gradient? Well, gradient m is change in y divided by change in x, isn't it? Okay, so again, if I'm going from this point down to there, can you see I'm going along 4 units and down 4 units, so that's 4, 4. So then the gradient then, change in y, it's actually minus 4 because it's going down rather than up, and change in x is 4. So it's negative 4 divided by 4. I just realized I've gone off the page. Let me just shimmy it over a little bit. Come over. Does that fit? Yep, I think that's kind of on the page. So, oh, I lost part of my digit there, and that should be a 4. I kind of lost half the 4 when I moved it. Okay, so it's minus 4 over 4. And negative 4 divided by 4, that is negative 1, isn't it? So the gradient is minus 1, and the y-intercept is c. So the equation of that line then is going to be y is equal to minus 1x or minus x plus 6, or 6 minus x is probably a neater way of writing it down. So I'm just going to spin that around and rewrite it as 6 minus x. Okay. So that's the equation, but what is the inequality? Okay, which way round does the inequality have to go? So remember I picked a kind of a reference point earlier, 4, 5. So which way around is that going to be then? So if x is 4 and y is 5, then is 5 less than or greater than 6 minus 4? Well, 6 minus 4 is 2. So 5 is bigger then, isn't it? 5 is bigger than 6 minus 2. So the inequality is going to have to go that way around. So the inequality is y is greater than or equal to 6 minus x. Okay? So then I've got my kite. Question 13. The height, 8 centimeters of each member of a tennis club is recorded. The histogram shows some of the results. So I've got 2 bars of my histogram shown. Now it says 40% of the members have a height in the interval of 160 to 170. Now that is, so this here then is got to be this bar, isn't it? So that is 40% of the membership in there. That represents 40%. It says 30% of the members have a height interval between 170 and 180. That is not drawn. And 100% of members have a height between 140 and 200. Okay, and again, not drawn. Okay, so what we're going to do here then. Now, we should be able to work out from the information of the bar that I do know everything about, what I need to know, I think. Now, I think I'm going to have 4 bars altogether here. Okay, so I'm going to kind of try and recreate the table alongside it as I go along. Okay, so heights for my club members. The first one goes from 140 to 160. Okay, the second one goes from 160 to 170. Then I haven't got the 70 to 80 bar, but you can see that was one of the things they talked about. So that goes from 170 to 180. And then I'm going to have another bar from 180 to 200. Okay. Now, so what I want to know is working out like the frequency percent. I'm just going to stick with percentage because I don't know. I'm just going to assume it's out of 100. Okay, so I know that the 160 to 170 bar, that's out of 40%, isn't it? That's 40% of our members. Okay, altogether it's going to be 100% because 100% is everybody. So I need to find out the percentage of the other 3 bars. Okay, now the bar I've been given, that has got a width there of 10 units, isn't it? It's going from 160 to 170, and it's got a frequency density of 3.2. So then the area of that bar is equal to 10 times 3.2 then, isn't it? So that's 32. So then that has got to be the actual frequency then, isn't it? That's the actual frequency, so that's 32. Okay. So the other bar I've been given, that's 140 to 160 bar. That has got a width of 20 and height of 0.7 in that direction. So it's got an area, maybe I should call that area 2, and this can be area 1. that's going to be 20 times 0.7. So that's got an area of 20 times 0.7, that's 14, isn't it? So I think that's got a frequency of 14 in there. Okay, so if 40% is 32, then 10% is going to be a quarter of that then, isn't it? What's 32 divided by 4? That's 8. So that means that if I then times it by 10, I'm going to 100%. That means there's 80 people altogether. Okay, how did I do that? 32 divided by 4 times by 10 and give me 100%. So that's 80 people altogether. So then what percentage is the 140 to 160 bar? 14 out of 80 then, isn't it? What's that as a percentage? 14 divided by 80. That is 0.175. So that's 17.5%. I'm not sure if these percentages are important. I suppose they are, because I know that 30% of the members have a height interval of 170 to 180. So that's going to be 30%. So what's 30% of 80? So 0.3 times 80. That's 24 then. Okay, so who's left over for the last bar? Well, I haven't drawn that one on yet, have we? We're going to have to draw that bar on, but let's just finish this off. What's left? So I've got 14, 32, and 24. If I take that away from 80, so 80 minus 24 minus 32 minus 14, that leaves me 10 to go here in the last bar then, isn't it? Okay, so I know the frequencies then for each of my heights. I'm just going to shimmy this over again a bit because I want to put the frequency densities on. Okay. I don't want it going off the end. So frequency densities, we already worked those out, or we already know what they were for two of them. For area 2 it was 3.2, wasn't it? And for area 1 was 0.7. We just took those off the graph. Now I need to work out the frequency densities of the other two bars so I can actually draw them on. The third bar, 170 to 180, that's got a width of 10 and it's got a frequency of 24. So the frequency density is the frequency divided by class width, so it's going to be 24 divided by 10, that's going to be 2.4. okay, and then the final bar has got a width of 20 and it represents 10 people, so 10 divided by 20, that's 0.5. okay, so I've got all the information I need to draw on my last two bars then. So the 170 to 180 bar should be at 2.4 then. So 2.4 is kind of here, isn't it? So my bar goes to there. It's not really very clear, is it? Should I go for a slightly thicker pen so you might be able to actually see it on the computer screen? Let's just go for a slightly thicker version of this pen. Does that stand out a bit more? Okay, and then the final bar, it has a width of 20, it runs from 180 to 200 and has a height of 0.5. okay, so 0.5 is here, it runs all the way across. Okay, so that's my completed histogram. It's quite tricky, that one, I think, to kind of piece it together. Okay, but then it was worth 6 marks. Question 14, find the coordinates of the turning point of the graph y equals x squared plus 6x plus 17. Now, when you are finding the turning point, what you are doing is you're completing the square run, isn't it? You want to find that kind of dip at the bottom of your parabola, and the way we do that is by completing the square. Okay, so rewriting this quadratic in completed square form, what we do is we take these first two terms and rewrite it as x plus something all squared. Now that something all squared, that is always half of this value here, so half of 6 is 3. Now if I actually multiply out x plus 3 squared, x plus 3 all squared. I'm going to get, well, it's going to be x plus 3, isn't it? Which is going to give me x squared plus 6x plus 9. I've kind of introduced 9 more than I had to start with because I'm replacing x squared plus 6x with x squared plus 6x plus 9 if I replace it like that. So I need to take off that extra 9 I've introduced. But plus, of course, I've still got this plus 17 that I haven't done anything with yet. So that's still there hanging out on the end of my, my expression there. So then all I've got to do is tidy this up a little bit. So x plus 3 all squared stays the same. I'm just going to kind of combine those two numbers at the end. 17 take away 9. That is equal to 8, isn't it? So that is plus 8. Okay, so what are the turning points then? So y is equal to x plus 3 all squared plus 8. Now the lowest value of that expression can be is, well, when you square something, it's always a positive number, and the lowest number of square number could be a 0, and you'll get that 0 value when x is negative 3, because negative 3 plus 3 is 0. So x equals negative 3 will give you the lowest value on the graph, and when x is negative 3, the bracket will disappear and you'll just be left with y is equal to 8. Okay, so this is going to have coordinates minus 3 and 8. Question 15. Here is the first 4 terms of a quadratic sequence. Got minus 1, 3, 13 and 29. We're told that the nth term is an squared plus bn plus c. Find the values of a, b and c. Don't be scared by this bit here. This is just a general form of a quadratic, isn't it? Quadratic expression, an squared plus bn plus c. And that's what you're doing when you're finding the nth term of a quadratic sequence. It's going to be in that form, isn't it? Okay, now people teach this in different ways. I know a lot of teachers teach it as finding the second difference and halving that, and that's going to be your n squared term, and then doing a bit of jiggery pokery to find the b and the c part of it. I'm not a big fan of that method because I don't think it makes sense to students why it is what it is. So if you are used to doing minus 1, 3, 13, 29, looking at the difference, that's going to be 4, 10, 16, and then the second difference 6, 6, and so on. So that tells you that it's going to be something to do with 3n and so on and so on. I don't like doing it that way. If you can do it that way and you're happy with it, stick with it. If you are just learning how to do it, I prefer to do it using kind of algebra and forming simultaneous equations and solving it that way. Let's have a think about the nth term. If the nth term is an squared plus bn plus c, now the first term, n is equal to 1, isn't it? So if n is 1, then if I sub 1 into this general form, an squared plus bn plus c, then you can see that 1 squared is 1. So I'm just going to get a for my first term, a times 1 squared, which is just a, plus bn, b is b and n is 1, so that's just b, and then plus c. So I'm going to get a plus b plus c, and I know that for the nth term, for the first term, n is minus 1, isn't it? So that is equal to minus 1. So I've got an equation in a, b and c, and it's equal to minus 1. Then what I'm going to do is use n is equal to 2. When n is 2, an squared, then n squared, 2 squared is 4. So I'm going to get 4a plus bn. N is 2, so that's 2b plus c. And that is equal to the second term of my expression, which is 3. Okay, so can you see I've got simultaneous equations in a, b, and c. Now I've got 3 unknowns, so I'm going to have a third equation to find 3 unknowns. So I'm going to go for n is equal to 3. Now this might look a bit weird, but it's the same for every quadratic sequence. So once you've done a few of these, you kind of recognize what I'm doing. So when n is 3, then n squared is going to be 3 squared, which is 9. That's going to give me 9a plus bn, n is 3, so that's 3b plus c, and that's going to be equal to the third term of my expression. Okay, now I don't need to use the fourth one, that's overkill for my purposes. I'm just going to use those 3. Okay, so what we're going to do? What we're going to do is we're going to take our 3 equations in 3 unknowns, and reduce them to 2 equations and 2 unknowns, and then 1 equation and 1 unknown. How are we going to do that? Well, let's say this is equation 1, 2, and 3. Then equation 2 take away equation 1. So if I take everything in equation 1 away from equation 2, so equation 2 is, I'll just write out again. I probably wouldn't bother if I'm doing it myself, but just because I'm explaining it, I'm going to show it again. Otherwise, I would just work it out. That's equation 2, and that's equation 1. So then if I subtract one from the other, then 4a take away a, that is 3a. 2b take away b, that is b. And c take away c, that is diddly zip. They cancel out, don't they? So we've got rid of c. And then 3 take away -1, that is equal to 4. Okay, so we've eliminated c, so now we've got an equation in a and b by taking equation 2 away from equation 1. Now, that's not good enough because I still don't know what a and b are. So I need another equation in a and b, and I'm going to get that by taking 2 other of my equations that I've formed and taking one away from the other. So now I'm going to take equation 3 and I'm going to subtract equation 2. That's going to give me 9a plus 3b plus c equals 13. And I've got 4a plus 2b plus c is equal to 3. And I'm going to subtract those. Okay? Now this might seem really complicated, but let's say it's exactly the same every time you solve this. So if I gave you a different quadratic sequence, you would be doing exactly the same thing with exactly the same values every time. The only thing that would change is the numbers on the end. Okay, so then 9a take away 4a, that is 5a, and 3b take away 2b is b, and c take away c, zip, and then 13 take away 3, that is 10. Okay, so now we've got 2 new equations. We've got equation 4 and we've got equation 5. Equation 4s and 5 are both in a and b. Okay, so we can now take those 2 simultaneous linear equations and solve them because we've got 2 equations and 2 unknowns now. So then what I'm going to do then is I'm going to take equation 4 away from equation 5. So equation 5 subtract equation 4. That is, what's that then? So 5a plus b equals 10. That's equation 5. And equation 4 was 3a plus b. That's equal to 4. Subtracting one from the other. 5a take away 3a. That's 2a, isn't it? b take away b. That's zip. And then 10 take away 4. That is 6. So 2a is 6, so a is equal to 3. Okay, so now I've got my value of a. I can then sub back into one of my equations, either 4 or 5, to find b. So I think I'm going to do it over here because I'm running out of space. So substitute a equals 3 into equation 4, let's say. Okay, so equation 4 was 3a plus b is equal to 4. So 3 lots of a, 3 lots of 3 plus b is equal to 4. Okay, so what does that make b then? So 3 3s are 9, 9 plus b is 4. So taking 9 away from both sides, that means b is equal to 4 take away 9, that's minus 5, isn't it? Okay, so that tells me what b is minus 5. And now I know that a and b, I can substitute back into one of my original equations, 1, 2, or 3, to find my final value c. Okay, so I'm going to sub into equation 1. So substitute a is 3 and b is minus 5 into equation 1. And that should tell me what c is. Okay, so what have I got? A plus b plus c is minus 1. Well, a I said was 3, plus b, which we worked out was minus 5, plus c, which we don't know yet, that is equal to minus 1. Okay? So 3 minus 5, that's minus 2. So c minus 2 is equal to minus 1. Adding 2 to both sides, that tells me that c is equal to 1. Okay, so now I know my value of A, it was 3. Now I know my value of B, which is minus 5, and I know my value of C, which is 1. And I know the nth term is the form an squared plus bn plus c. So now it's just a matter of plugging those 3 numbers into that expression to find the nth term. So therefore, the nth term is a 3 n squared plus b negative 5 n plus c plus 1. So that's my nth term, 3n squared minus 5n plus 1. Okay. Now I find this a very logical way of doing it. Probably the first time you're looking at it, you're thinking that's a lot of algebra. But like I say, 99% of what I've done is the same for every quadratic sequence that you do. Okay, and by 99% I mean nearly everything. So all of this, 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 all of this is going to be the same. The only thing that changes are these numbers on the end, because you get those from the actual sequence that you're looking at. So all the actual algebra is the same from one question to the next. So whilst it looks long and complicated, you know, after you've done 5 of these and it's the same every time, you go, oh well, that's the same every time, and it gets quite straightforward to do. So I like it this way. I think it's easier than the other way, but it's for you to decide. If you prefer to do your nonsensical way of doing the common second differences and halving it, even though you have no idea why, you just carry on with that. That's no problem at all. I'll leave it to you to decide, as always. Question 16. The formula P equals 6,800 times 1.045 to the power of n is used to predict a population P of an island n years after 2018. Write down the population in the island in 2018. Okay, so if it's the actual year 2018, then n years after that, n is going to, we're talking about n is equal to 0 here, aren't we? N is equal to 0, okay? Because it's n years after 2018 and it's 0 years after 2018 if it's actually 2018. Okay, so what we're talking about here then is population is equal to 6,800 times 1.045 to the power of 0. And you should know that anything to the power of 0 is just 1, and anything times 1 is just itself. So it's just 6,800. Okay, write down the percentage growth rate used in the formula. Well, it comes from here, isn't it? 1.045. 1.045 is the multiplier. So the multiplier is 1.045. So the percentage is 104.5%. So the percentage growth rate, subtracting 100%, is 4.5%. Because remember, everything starts at 100%. So if you're doing a multiplier of 4.5%, or you want to work out 4.5% increase, you have to add 4.5% onto 100%, and so on. So the growth rate is 4.5%. C part 1 says work out the population predicted by the formula for the year 2030. So remember, the formula was population is equal to 6,800 times 1.045 to the power of n, where n is the number of years after 2018. So what is n first off? 2030 minus 2018, what's that then? That is a difference of 12 years. So n is equal to 12 here, isn't it? 12 years after 2018 is 2030. So the population is going to be 6,800 times 1.045 to the power of 12. What's that then? 6800 times 1.045 to the power of 12. I make that 11,531.9. Well, 99. I'm going to round that up to 11532. So 11532. Give one reason why the answer to C part 1 may not be reliable. Well, this model assumes that everything stays the same for the whole 12 years, doesn't it? So But you know, things happen, don't they? You know, wars, famines, and whatever. So things can change over time. The situation can change. So the model assumes that the growth rate stays the same the whole time, but there may be circumstances that cause it to change. I'm just going to write down a few, like e.g. war, famine, etc. Any reason could be a good thing as well. I don't know. People could be given more taxes to have babies. I don't know. Question 17. The diagram shows triangle ABC. AC is 48 millimeters, BC is 85 millimeters, and angle BAC is 53 degrees. Calculate length AB. You must show your working. Okay, so we've got sides and angles in a triangle, and we want to find another side. So this is screeching trigonometry at me, but it's a non-right angle triangle, so it isn't SOHCAHTOA here, is it? It's either the sine rule or the cosine rule. But which one is it? Well, now you've got this handy rule here. The sine rule is about opposites. So have we got opposites here? Well, we've got one pair of opposites. This one is opposite this one, and we know both of those. But we've got this side here, and the opposite angle is over here, look, which we don't know. We actually want to find this side here, which is opposite this angle that also we don't know. Okay, so it's not a straightforward use of the sine rule. Is it the cosine rule? Cosine rule is about three sides. So either you know two sides and an included angle and you want to find a third side. Let's just get rid of that and consider it. So the cosine rule is about three sides of a triangle and using it to find an angle, or it's that you know two sides and an included angle and you're using that to find the third side. Now again, what we're missing is that angle down here in order to use the cosine rule. So it's not a straightforward use of the cosine rule either. I think what we're going to have to do here is apply one of the rules twice, either sine rule and then cosine rule, or sine rule and sine rule. I kind of prefer the sine rule to the cosine rule. I think it's easier. So if I can get away with doing two sine rules rather than the sine rule and cosine rule, or two cosine rules, that is what I'm going to do. Okay, so I think what I'm going to do is I'm going to start off with the sine rule. I'm going to use this pair that I know to find the pair opposite that one. I'm going to use that to find that angle there. Now once I know that angle, I'll know two sides of the two of the angles inside the triangle, and I can use triangles adding up to 180 to find that one. And once I know that one, then I can use the sine rule to find that one over there. Okay, so that is my attack plan. Sine rule times 2. Okay, so let's do that to start with. So I'm going to use first off these two and this one to find this one down here. That's what I want to do. Okay, so what does the sine rule state? Now you can write the sine rule either way up, either with the angles on the top and the sides on the bottom, or the other way around. And the way that I write it down is I write the thing that I want to find on the top. Okay, so I'm going to start off with sine A over A equals sine B over B equals sine C over C. Now we only ever use 2 bits of the sine rule, not all 3. Now in this case, I want A, I want B, I don't care or need C right now. So I'm going to use the first 2 bits. Sine A over A equals sine B over B to start with. Okay, so sine A, that's 53 degrees, isn't it? So that's 53 there. So sine 53 over side A, that's that one there, that's 85 over 85, and that is equal to sine B, angle B is the one I want to find. So I'm just going to leave it as sine B for now. And I'm going to divide that by side B, which is that one over there. So B is going to go there. That's my 48. Okay. So you can see there's only one thing I don't know there. That's sine B. So rearranging to make sine B the subject. So basically I'm going to just cross multiply that 48 over there. So I'm going to get 48 sine 53 over 85. And that is equal to sine B then, isn't it? Okay. So I'm going to type that into the calculator. So what I want is 48 sine 53 divided by 85. Okay, what's that? That comes out to be 0.45099, etc. But I don't want sine B, I actually want B. So I'm just going to do that in 2 steps. I'm going to say shift sine, the inverse sine of my answer. What's that? 26.8. So I can say that B is 26.8 degrees. Okay, and there's a bit more to it than that. I'm just going to leave that number on my display because I'm just going to crack on with that in a minute. Okay, so that is my angle B. So now I know angle B, I should be able to work out angle C, shouldn't I? So angle C over here then, using angles in a triangle, then I know that angle A plus B plus C is 180. So angle C then is going to be 180 minus angle A, which was 53, plus my angle B, which was 26.8. Remember, I'm going to use my calculated store value. So answer plus 53, and take that away from 180 minus answer. That comes out to be 100.2. Okay, roughly. Okay, again, I'm just going to keep that full display value in my calculator screen. Okay, now finally I want to find the side AB. Now the side AB is actually side C, isn't it? If we're being consistent with the sine rule. So this time I want a side, so I'm going to write the sine rule the other way up this time. So A over sine A equals B over sine B equals C over sine C. Okay, now I want the C's this time because I've now found angle C and I want side C. I'm going to stick with A because they were the values I've been given. So I'm just going to drop B. I'm going to use A over sine A equals C over sine C. Okay, so A is 85, isn't it? So 85 over sine A. Sine A is 53, isn't it? So sine 53 is equal to C. Well, that's what I'm trying to find, over sine. Well, that's the C I found earlier, isn't it? 100.2. Okay, so that's going to be sine 100.2. Okay, so then rearranging that, I'm going to cross multiply that up there. So I'm going to get 85 sine 100.2 over sine 53. Let's just budge it up a little bit. Okay, and then that is going to be equal to my side C. Okay, so 85 sine, I'm going to use the answer key because I want that to retain accuracy. So 85 sine answer divide by sine 53. That comes out to be 104.75. So C equals 104.75. I think I'm just going to round it off to 105. 3 significant figures seems reasonable, doesn't it? So I'm going to round it off to 105. What's the units? It's in millimeters, isn't it? So 105 millimeters. Question 18a. For each graph below, select a possible equation from this list. And we've got a list of 8 different possible graphs that we should know what they look like. Part I has a periodic graph. It starts low and ends high. Now, the only periodic graph I know that doesn't kind of go up and down is tan. So it's got to be that one there, tan. So I'm going to write down tan x. Part 2 has got a graph that's hugging the x-axis in the negative quadrant here, down here. And then as you go further to the right, as x increases, the rate of change increases. This is an exponential curve, isn't it? So it's got to be something where x is the power rather than just a kind of a variable. So it's going to have to be this one here then, y equals 3 to the power of x. That's the only exponential curve we've got in the list. So y equals 3 to the power of x. Part B says, here is a sketch of y equals x cubed. On the axis below, sketch the graph of y equals negative x cubed. Okay, so we've got a graph transformation here, haven't we? We've got some function f of x, and it is going to minus f of x. Now, this type of transformation, where you stick a negative sign in front of the function, that has the effect of flipping the graph over in the x-axis. We call it a reflection. So this is a reflection in x-axis. Okay, so basically what is on the bottom of the left-hand side is now going to be on the top, and what's on the top is going to be on the bottom. So my graph is going to have that same shape of a cubic curve, but the other way up. Okay, so it's going to start high and then low like that. Okay, and for part 2, we need to plot y equals x cubed minus 8, showing the values of any insets with the axes. Okay, so with this one, we've got a function of x going to the same function of x with 8 taken away from it. Okay, now this type of transformation is a translation of 8 units well, minus 8 units, I suppose, in the direction of y. Okay, so then basically every point on my graph is going to appear 8 units lower than it is. Okay, now there are no kind of marks on my graph, so I don't have to worry too much about it. I just need to draw the same shape, but that is going to kind of cross through the y-axis a bit lower than it currently does. So something that looks a bit like that. Okay, so I need to show the intercepts. Well, this one down here is fairly easy because it was at 0, 0, and I've moved it 8 paces down. So then that is going to be at negative 8 down there, isn't it? Now this one over here is a little bit more tricky. I need to solve really, don't I? So I need to know when x cubed minus 8 is equal to 0. I want to find the root of this equation. Okay, so rearranging that, adding 8 to both sides, I'm going to get x cubed equals 8, and then taking the cube root, I'm going to get x is equal to 2, isn't it? So that point there is 2. Question 19. ABC is an isosceles triangle. The sides of the triangle ABC are all tangents to a circle of radius 6 centimeters, center O. Angle BAC is 70 degrees, and BA equals BC. Show that the length BO is 17.54 centimeters, correct to 2 decimal places. Well, oh my, this is going to be fun, isn't it? Okay, where to start? Well, let's just add on our extra angles. So this is an isosceles triangle, so that one down there is also going to be 70 then, isn't it? Because that's the other base angle of the isosceles triangle, which makes this one at the tip 70 plus 70 is 140. Take away from 180, and that's going to be 40 up there, isn't it? Okay, so I've got 40, 70, and 70 on my diagram. Now this is a show that question, so I feel like we should probably write down the reasoning as we go through when we're finding these angles out then. So I'm saying that ACB, the bottom angle, is equal to CAB, which is equal to 70 degrees because it's an isosceles triangle. And we know that ABC equals 180 degrees minus those two 70-degree angles. which is equal to 40 degrees. And that's because of angles in a triangle, sum to 180 degrees. So kind of for each step, I'm just going to give a quick reason for what it is and why it is. Okay. Right, so that's the angles in the triangle. What do we actually need to find though? Length BO. Where's BO? Okay, that's not actually marked on the diagram. Let's just draw it in. So BO then is this line here. I'm kind of seeing a triangle in here. Can you see where the angle here is going to be half of that angle at the top? And it's a right angle triangle. And I know one of the sides. So I think I can use trigonometry in here to work out that triangle. To work out the hypotenuse of that side then. I'm just going to pull the triangle out of my diagram. So in triangle, well, it doesn't have a name, does it? Because I don't have a point. Let's call that point there M. So in triangle MBO. Okay, let's just draw it. I'm going to take the triangle out and I'm going to draw it on the side. Okay, so that was the right angle. That was 20 degrees at the top. And then that was 6 centimeters, wasn't it? That's B. That's my point M that I wrote down, and that's O. Okay. I'm going to say angle MBO is half of that angle at the top there, which is 20, isn't it? Okay, because basically this line BO is going to bisect this angle in two, isn't it? It's going to cut it in half. Okay, so that's 20 degrees. And then so what we need to do then is to use now trigonometry in this triangle to find the hypotenuse, don't we? This side here is the hypotenuse. This one is opposite the side of the angle, and this one is adjacent. So SOHCAHTOA, which one are we going to use? SOHCAHTOA. Which ratio do we need to use here? Well, we want the opposite. So we've got the opposite. We want the hypotenuse. We're not interested in the adjacent. So any of the ratios that got an A in it, we can kind of get rid of. It's just the one there at the front. So that's the one we want. Okay. So then write down the full trigonometric ratio, which is sine theta is equal to op over hype. Okay. And then sub in from my picture. So I know that the angle is 20. So sine 20 degrees is equal to the opposite, which we know is 6, divided by the hypotenuse, which is what we're trying to find. Okay, I'm going to give it a letter, I think. So I'm going to call it x. So over x, because I don't like writing hype down in the formula, it looks wrong. And then rearranging, you can just cross multiply these, can't we? Just kind of switch them over. You can do it in 2 steps if you find this tricky. X equals 6 over sine 20 degrees. You can multiply through both sides by x and divide through by sine 20 if you're not happy with cross multiplying. And then we've got this thing that we can then type into our calculator. 6 divided by sine 20. So 6 divided by sine 20. I make that. Oh, look, 17.54. Perfect. Equals 17.54 centimeters to 2 decimal places. Part B says find the area of triangle ABC. You must show your working. Now to find the area of a triangle, we need to know its base and its height, isn't it? So area of a triangle is a half base times height. Do we know either of those things? Well, we just found part of the height, didn't we? So if you remember, we found this distance here, BO, from here to here. Okay, and we found that was 17.54, but we also know what this little bit down here is, because that is the radius of a circle. So BO was 17.54, and that is 6 because it's a radius. So then B all the way down to the bottom, so the height of this triangle then is going to be 17.54 plus 6. So H equals 17.54 plus 6, which I make to be 23.54. Okay, so that's my height. Can I work out the base? Now remember, this angle here was 20 degrees, and if I've got the height, I should be able to work out. So if I know this side here, I should be able to work out half the base anyway, because this is a right angle triangle, isn't it, that I've kind of formed here. So I'm going to use SOHCAHTOA again. I'm going to use, but in a new triangle. So I'm going to do it in triangle. Now I want to refer to a point that I don't have on my diagram, so I'm just going to add another one in. So I'm going to call this point here N. So in triangle ABN, then what's going on? Well, let's just draw it again. I kind of like to take it, if I got a complicated diagram, I like to take the little bit that I'm looking out so I can kind of draw on it and look at it in isolation from the rest of the diagram. So just quickly drawing that part of the triangle. So I know this is a right angle. This is the point N. This is B up here. This is 20. This is 70 degrees, and this is A. So what's what on this diagram then? Okay, so I need to pick an angle for trigonometry. Let's use the 70 because that's the one that was given to us. I'll use that one down there. Then angles relative to that angle. This one over here is the opposite. This one is the adjacent. This is still the hypotenuse because it's the longest side. Now, right now, our handy mnemonic again. SOHCAHTOA. What we got now? So this time, I know. Oh, sorry, I forgot to write the length on here. This was, we said, was 23.54. So we know the opposite. It's here. Look. What we want this time is the adjacent, isn't it? Okay, I don't want the hypotenuse, not interested in the hypotenuse. So anything with a h in it, don't care about this time. So it's tan. Tan is what I want. So writing down the full ratio, tan theta is equal to op over adj. Okay, then what have I got then? So tan theta, tan 70 is equal to the opposite, which we know is 23.54, and we're going to be dividing through by the adjacent, which is what we're going to find. Okay, so I'm going to have to give another letter to my diagram. I'm going to call this side y. Let's call it like that. Tan 70 equals 23.54 over y. And then we're going to rearrange for y then. That side that I want to find. So I'm just going to, again, I need to cross multiply these around. They kind of swap over, and I'm going to get y is equal to 23.54 divided by tan 70. What is that then? Now I've still got my last calculated value stored in the calculator, which is a little bit more accurate than my 23.54. So I'm going to use that instead. I'm going to add 6 to it to get 23.54 and change, and then I'm going to divide it by tan 70. By doing that, you just kind of retain a little bit more accuracy in your work. Not so important for GCSE, but it's good practice for A-level. Right, so that comes out to be 8.5688, which I'm going to round off to 8.57. And that's going to be in centimeters, isn't it? Now, that isn't quite what we want, though, because that's just this distance from here to here, then, isn't it? So what we want, then, is double that. We want to find the base. So the base is going to be all the way across from A through to C. So AC is going to be 8.57 times 2. Again, I'm going to be using my calculator value rather than 8.57. Just going to multiply that up by 2. I get 17.13. So I'm just going to say that's equal to 17.1. Okay, and then that's going to be my base then, isn't it, from my calculation up here. So that's going to be 17.1. Now I know everything I need to find the area of this triangle. So I can say then that the area of the triangle is half base height, which is a half times 23.54 times 17.1. Okay, so what's that? Times 23.54 divided by 2. That comes out to be 201.7. Just going to round off to 202 centimeters squared. Okay. It's quite long that, wasn't it? Quite tricky. Question 20. Solve algebraically y equals x plus 3 and x minus 3 all squared plus y squared equals 50. Okay. Now the first one is an equation of a straight line. If you didn't know, the second one is actually an equation of a circle. It doesn't look like you normally see at GCSE, x squared plus y squared equals something, because this one is a kind of a slightly offset circle. I don't think that's massively important for this question, but basically it's going to be an offset circle. So the center is off at x equals 3, if you're interested. And then y equals x plus 3. That's going to be like a straight line passing up through there. I suppose it kind of is important, because I'm looking for. It tells me I'm looking for probably 2 points of intersection, or maybe one if it's a tangent. Okay, so that's kind of what's going on here. But how do we solve this algebraically? This is clearly a job for substitution, isn't it? Solving by substitution. I'm going to take equation 1, this first one up here, and I'm just going to sub it in where I see y in equation 2. Okay, so that's what I'm going to do. Substitute equation 1 into equation 2, and that's going to give me x minus 3 all squared plus y squared. Well, y is x plus 3, so that becomes x plus 3 all squared, and that is equal to 50. Okay, so let's just expand those brackets. I'm going to get x minus 3, x minus 3. Don't be that guy who just squares x and squares 3 and thinks that's it. It's not. You have to expand them. Okay, like that. Okay, and then I use the identity a plus b all squared is equal to a squared plus 2ab plus b squared. Actually, when I do these, I don't tend to expand them like this. I go straight in and I do these 3 terms. But anyway, so I would do the first term squared, which is x squared, plus 2 lots of the 2 things multiplied together. So x times minus 3 is minus 3x, and doubled up is minus 6x. And then the last term squared, 3 squared is 9. So I get x squared minus 6x plus 9 for the first bracket multiplied out. Similarly for the second one, I'm going to get x squared, but this time I'm going to get plus 6x in the middle, plus 9, and that is equal to 50. Okay, you can probably see that my x terms disappear. They cancel each other out, but the others kind of add. So I'm going to get 2x squared plus 18 is equal to 50. Taking 18 away from both sides, that's going to give me 2x squared is equal to 32. Dividing through by 2 is going to give me x squared is equal to 16. And then square rooting, I'm going to get x is equal to plus or minus 4. Okay, don't forget the minus 4, because there are 2 solutions. So if x is 4, what's y? So when x is 4, then y is going to be 4 plus 3. That's going to be 7. And when x is minus 4, y is going to be minus 4 plus 3, which is minus 1. Okay, so they're the parents we've got then. So 4 goes with 7, and minus 4 goes with minus 1. Okay, and that's going to correspond to those 2 points there. That's going to be the 4, 7, 1 then, isn't it? And that's going to be the minus 4, 1 there. Okay. Good-o. I think we're done. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.